And if it is fluorine, it is going to be -1. And if it is hydrogen, it is going to be -1 with metals and +1 with non-metals. And oxygen, on the other hand, will usually show -2, but it has various oxidation states. For instance, if you take H2O2, it would have -1 oxidation state. And when you have -1, we read oxygen as peroxide. And
Just
similarly,
1 second for the hydrogen.
yes, madam. Any doubt there?
Clear, sir.
Right. And then we saw about KO2, where oxygen has -1/2 oxidation state. We call that kind of oxides as superoxides. We learned about how to find the oxidation state in various cases, including KMnO4, K2Cr2O7, all of this, right? So up to this point, I hope all of you have an idea about what is oxidation state, how it is being taken care of, right? Now coming to the next part here, like considering we know how the oxidation state works, this oxidation state, in observing this oxidation state in various cases, is what we will learn about redox reactions. So first, let me get the terminology clear. When do we say something is redox reaction? A redox reaction is said to be happening if there is an oxidation plus reduction both taking place. Now that brings to the case, what is oxidation exactly? Oxidation in the olden days, that is before even starting with oxidation numbers, oxidation was believed that addition of oxygen, for example, carbon is getting added with oxygen. So we say, okay, carbon got oxidized. We say carbon got oxidized, which means it has been combined with oxygen. Similarly, if you have N2 plus O2, and in case if it becomes NO2, we say nitrogen got oxidized. Clear? If we have C2H6 plus O2, so again you can see this will form CO2 and H2. So both carbon and hydrogen both got oxidized. Clear? This was the basic definition, that addition of oxygen is oxidation. And the other definition which was fitting is that, you see, if this alkane, if I remove hydrogen and replace that with oxygen, that is in fact oxidation itself. So we can say removal of hydrogen or addition of oxygen is oxidation. So either ways, if you have a removal or an addition, okay, removal of hydrogen or addition of oxygen, both is called as oxidation. Like for example, iron, if you treat with O2, it is Fe2O3, then iron got oxidized. And if you have something like CH4 treated with O2, and if it converts to CO2 plus H2O, we say carbon got oxidized because it has reduced the hydrogen number. So even if you reduce the hydrogen number, it is going to get oxidized. So I hope you got an idea, right, students? Modern definition of oxidation is actually loss of electrons. Oxidation, in the modern definition, is loss of electrons. Got it? For instance, if at all I have a metal, sodium, and it is losing out one electron, so we say sodium got oxidized. We say this got oxidized. Okay. So any element, if it loses an electron, so for example, H2 gas, H2 as a gas, if it becomes 2H plus 2 electrons, we say H2 got oxidized. We say this got oxidized. Same way, we can have iron. If iron is becoming Fe plus 3 electrons, for any element, you can write down that. Like if there is a loss of electrons, it is oxidation. Any doubt till this point, students? Right. What is reduction then? A reduction is said to be the case where we are reducing the carbon oxygen numbers or increasing the hydrogen numbers. So loss of oxygen or gain of hydrogen is reduction. Loss of oxygen or gain of hydrogen is reduction. So for instance, if we take something like Ag2O, on heating, this will become Ag plus O2, half O2. Now what happened? From Ag2O, oxygen has been lost. So since oxygen has been lost, we can say this has undergone reduction. So I can say silver got reduced. This is silver got reduced. This is removal of oxygen case. Addition of hydrogen. Any addition of hydrogen is always called reduction. For example, if you have CH2 double bond CH2 and you're adding one H2 to this, it will become C2 C2H6. So which means hydrogen got added to this. So we say this compound got reduced. So addition of hydrogen or removal of oxygen is a reduction process. Or the modern definition is that addition of electrons. Addition of electrons is reduction. Addition of electrons is reduction. For example, if you have Cu2 plus one electron got added and it will become Cu plus, this is reduction. Or if you have Sn4 plus 2 electrons and it has become Sn2 plus, this is reduction. If you have magnesium 2 plus 2 electrons and it is becoming magnesium, we say it is reduction. Or O2 gas plus 2 electrons giving 2O2 giving 4 electrons, giving 2O2 minus. So this is also reduction. Cl2 gas taking 2 electrons becoming 2Cl minus, that is also reduction. So these are all the cases where it is undergoing reduction. So I think all of you can realize that which is oxidation and which is reduction. Any doubt here, students? You guys can ask me, just make a note of it. What is oxidation and reduction? Then we'll go ahead. Just a minute. Finished? So I guess all of you got an idea like what is oxidation and what is reduction. Okay. Learning oxidation and reduction, we will focus on the modern definition more. That is gain of electrons or loss of electrons. Now, what I can say, the charge associated with any element, which we call it as the oxidation state. For example, if you have solid, this is zero charge on it. And if it starts gaining positive charge, like say plus or 2 plus or 3 plus, like this, which means it is losing out electrons every time. It is losing out electrons. So you can see the positive value is increasing. Positive value is increasing on an element implies that it is getting oxidized because it is continuously losing electrons. So here I can say m to m plus 3 or m to m plus 2 or m plus to m plus 2, m plus to m plus 3. These are all oxidation. So this direction, we are seeing oxidation happening. While on the other direction, if you look at it, so you add one electron, this will become m minus. If you add one more electron, it will become m minus 2 and so on. So on this direction, what do we have is reduction. This direction, what we have is a reduction. So I guess you got an idea like which is undergoing oxidation and which is undergoing reduction. Okay. So जहां पर भी ऑक्सीडेशन स्टेट में आपने पॉजिटिव चार्ज ग्रोथ देखा है, मतलब it is undergoing oxidation. If it is going towards the negative direction, we can say it is undergoing reduction. Okay. Now we know how to calculate the oxidation states, correct? Now tell me students, कुछ examples लेके मैं बताता हूँ. Suppose if we have carbon plus O2 is giving CO2. So please participate with me. What is the oxidation state on carbon? What is the oxidation state on carbon here? 0. Because as a pure form, anything oxidation state is 0. What is the oxidation state on oxygen? 0.
0.
Now, how do we calculate the carbon and oxygen oxidation state? I told you oxygen in generally always will have -2. And if that is -2, let carbon be x. So x plus 2 times of -2 overall equal to 0. So x is equal to +4. So on carbon, the oxidation state is +4. So can you see from 0 to +4, what is happening to the value? Increasing. Positive value is increasing, which means it is undergoing oxidation. While for oxygen, from 0 to -2, it is undergoing reduction. So what I can say in this case, beta, that carbon has undergone oxidation and oxygen has undergone reduction. Right. So I think all of you got this idea. Like what is the charge which is undergoing it to what? Okay. So now I'll give you few questions where you need to figure out reactants, what are their charges, and accordingly product, what are their charges, and tell me which is undergoing oxidation and which is undergoing reduction.
So please explain this example, carbon plus oxygen gives out CO2. Means how oxidation and reduction takes place.
Oxygen has 0 charge. Do you understand that, right, beta?
Yes, sir.
And oxygen is 4 charge. Did you understand that?
Yes.
If positive charge in the oxidation state is increasing, it is oxidation. This is what is happening. I told you, right? यहाँ से positive की तरफ जा रहा है तो क्या हो रहा है? Oxidation. If it is going towards negative side, it is reduction. So can you see carbon is undergoing oxidation, oxygen is undergoing reduction.
Okay, sir. Clear, sir.
Now do the same thing here, beta. Suppose if you have KMnO4 plus FeSO4 is giving Fe2SO4 thrice plus MnSO4. Okay. All I can give you the hint as take SO4 as a unit, and SO4 always will have overall charge of -2. That is one hint I can give you. From there, you should be able to tell me which element is undergoing oxidation, which is undergoing reduction, and how is it happening. Do it, everybody. What is the first thing we will do? First thing is calculate the oxidation state on manganese. Everybody do the check out on this manganese, what is the oxidation state?
Again, scroll up. Yes.
Right, students, tell me what is the oxidation state on manganese? Very good. So only one got the answer. What did you do in the last time? We discussed all of this. I'm repeating once again, these sessions are not supposed to be sessions where I can thoroughly go through point by point. If you don't come prepared, you'll suffer here, okay? Now, KMNO4 we already discussed last time. If you see, go back to the notes, you should easily find what is the charge on KMNO4. KMNO4. Potassium will be +1, manganese is X, 4 times oxygen is -2, 0. So X is equal to +7. So oxidation state on manganese is +7 here. What is the oxidation state of manganese here? Like I told you, you can take SO4 as 1 unit and SO4 is -2. If SO4 is -2, then Mn will be +2. So you can clearly make out from +7 to +2, there are 5 electrons being added. If this is added, then only we will get +2. Addition of electrons is reduction. So KMNO4 underwent reduction. Now see iron here. What happens to iron? SO4 is -2. So iron will become +2. So that is the oxidation state of iron. And what about the oxidation state of this iron here? If you look at this iron here, 1 sulfate is -2. So we have 2x plus 3 times of -2 equal to 0. So that is equal to 2x is equal to 6 or x is equal to +3. So +3. So +2 to +3, we have seen it is changing from +2 to +3. So +2 to +3 means 1 electron has been lost. 1 electron lost. So if there is a loss of electron, it is oxidation. So we can say KMNO4 is undergoing reduction, FeSO4 is undergoing oxidation. So yes, when this type of reactions are observed, we say it is a redox reaction. Everybody understood this logic? Do the next one. K2Cr2O7 plus Na2C2O4 is becoming Cr2SO4 thrice, Cr2SO4 thrice, and CO2. Check out the oxidation state of these elements and comment what is happening, which is undergoing reduction, which is undergoing oxidation. Okay, students, just give me a thumbs up if you all have understood the last 2 questions, KMNO4 and CO2. Right. Vaishnavi, is that clear, beta? Siddhi, did you understand? Siddhi, respond. Neil? Okay. Do this now. Find the oxidation state on chromium. First, give me these numbers, everybody. What is the oxidation state on chromium? What is the oxidation state on carbon here? Right, Shraddha. Work out on carbon also.
Chromium has +6, and in the
Write it down, write down there. Write down on the chat. Let others do. No, Shraddha, check once again, beta. About carbon, can you check once again? Na2C2O4. That is correct. I'm talking about Na2C2O4. Right, Anu. Next. Do it for carbon. Right, Vaishnavi. Correct. Do it on the right hand side, beta. So that is on the left hand side. Now do it on the right hand side. Right, Anu. Do the right hand side. I think most of you got the first two, left hand side. See, I'm first drawing for chromium here. For chromium, we can see it is +2 from potassium, plus 2x plus 7 times of -2 equal to 0. So 2x is equal to +12. So x is equal to +6. So this is the oxidation state on one chromium. Next, we'll do it for carbon now. For carbon, you can see it is +2 plus 2x plus 4 times of -2 equal to 0. So 2x is equal to 6. So x is equal to 3. So on one carbon, it is +3. Now chromate here. SO4. Yes, correct. Correct, Vaishnav. So, right. Shraddha, right. Shraddha, Shruti, correct. All right. Correct, Vaishnav. Yes, Anu, right. So chromium here, if you look at it, one sulfate is -2. So which makes one chromium as +3. And one carbon here is +4. We have done this already. So you can clearly make out from here, +6 to +3, the positive value is decreasing, which means it is undergoing reduction. Here, +3 to +4, positive value is increasing, which means it is undergoing oxidation. So yes, this is definitely a redox reaction. One is undergoing oxidation, the other one is undergoing reduction. Yeah. Do this now. H2O2 on decomposition, that is H2O2 on heating, will give us H2O plus half O2. Okay. Now check the oxidation state of oxygen here, here, and here. What is the oxidation state of oxygen here on the left hand side and on the right hand side?
Sir, hydrogen is +1 or -1?
That you should know, na? Don't ask me. Check your notes. Hydrogen is connected with what, beta? Oxygen, right? Is oxygen metal or non-metal?
Non-metal.
Non-metal. So what is the oxidation state of hydrogen? +1, right? So here, one oxygen is -1. I think all of you got that. So 2x plus 2 equal to 0. So x is equal to -1. Plus 2 is coming from hydrogen because every hydrogen is +1 charge. And there are 2 oxygens here and each one has x charge. So which is coming out to be -1. And oxygen here is -2. Oxygen here is 0. So you can see -1 to -2, it is reduction. And -1 to +0, it is oxidation. Clear? So oxygen itself is undergoing oxidation as well as reduction. Okay. So H2O2 goes oxidation also and reduction also. And same oxygen is undergoing oxidation and reduction. Okay. Now listen up.
Can we say this reaction as a disproportionation reaction?
I'm coming there, beta. Now, in these reactions, earlier reactions, what happened? There are two reactants, two different reactants, and they are getting oxidation and reduction done. Now, such type of reactions are called intermolecular redox reactions. Intermolecular redox. So the first two cases, whatever we have seen, in fact, first three cases we have seen, those are all intermolecular redox cases. But this is a case where only single element is undergoing oxidation and reduction. So that is called as disproportionation redox reaction. So this is disproportionation redox. Clear? Let me give you a few cases. If you check the last 10 years of KVPY papers, right? There is always one question on disproportionation for sure. So to do further problem solving in disproportionation, you got to know whether it is disproportionation or not. Equation दिया है तो आपको सबसे पहले यही find करना है कि whether this reaction is disproportionation or not. So like these examples, I'll give you a few more. For instance, if you have
that what you have tried after intermolecular.
What, beta?
So this H2O2 is disproportionation reaction. Then upper three examples are intermolecular
redox. Intermolecular redox. This is disproportionation redox. Okay.
Okay, sir.
Now listen up. P4 is giving PH3 plus NaH2 PO4. PO2, sorry, NaH4, NaH2 PO2. Now let me show you. As a pure molecule, oxidation state is always 0. And here phosphorus is non-metal, so X plus 3 into 1 equal to 0, X is equal to -3. And phosphorus here, if you look at it, sodium is +1, 2 hydrogens are +1, plus X, plus 2 times of -2 equal to 0. So X is equal to +1. Okay. So here also we are getting X is equal to +1. So you can see it is the phosphorus only which is undergoing the change from 0 to -3. So ये हो गया reduction. And from 0 to +1, it is undergoing oxidation. So we have reduction and oxidation taking place here. H2O, oxygen is -2 beta, hydrogen is -2, -1. Hydrogen is +1. So X is equal to -2 na beta. Shraddha, in water, your confusion is about water. See, H2O, there are 2 hydrogens here. So 2 into +1 plus X equal to 0. So X is equal to -2. There is a charge on oxygen. Okay. Clear? In the first case, there are 2 hydrogens. So that's why you'll have 2x plus 2 equal to 0. So X is equal to -1. So this is also a disproportionation reaction. So I hope all of you got this, how this is disproportionation, right? So disproportionation को समझना बहुत important है. Now let me give you one more case which is not disproportionation. Rather, if you see something like this, Fe2S3, Fe2S3, and this is undergoing change to Fe plus 2 plus SO4 2 minus plus S2O3 2 minus. Now, if this is the case, let me tell you, with respect to iron, with respect to metal, sulfur will always have -2 because it is similar to that of oxygen as it is falling on the same group. So we can say sulfur here is -2, and there are 3 of them, and plus 2 times of X equal to 0. So X is equal to +3. So iron oxidation state here is +3. And it is getting oxidized to +2. So +2 to +3, it is undergoing reduction. तो ये यहाँ से दिख गया हमको. Now coming to sulfur, there are 3 sulfurs, out of which 2 sulfurs are changing to S2O3 2 minus, and 1 sulfur is changing to SO4 2 minus. And every sulfur here on the left hand side has -2 charge. And there are 2 sulfurs here. 2 sulfurs included together, how much is the charge here? For 2 sulfurs, the overall charge is -4. And let us see what is the charge on 2 sulfurs here. So 2x plus 3 times of -2 overall equal to -2. So which makes it 2x is equal to +4. So overall for 2 sulfurs here, the charge is +4. This is for 2 sulfurs. For 1 sulfur, from -2 to 6 here, because SO4 2 minus sulfur is +6, and here it is -2. So can you see -4 to +4, what is happening? 8 electrons are transferring, and that too it is increasing in positive value. Positive value means this is undergoing oxidation. This is oxidation. So here this is also undergoing oxidation. From -2 it is going towards +6. So it is oxidation. So there are 2 oxidation reactions, oxidation steps, and 1 reduction step. So overall it is reduction only. Overall it is redox only. But there is only one molecule. You see, there is only one molecule, but 2 different elements. 2 different elements undergoing redox. Such type of redox are called as intramolecular redox. These are called intramolecular redox reactions. So here you can see iron is undergoing reduction, sulfur is undergoing oxidation, but both of them included, there is only one molecule. So within one molecule, there are 2 different elements. One element is undergoing reduction, one element is undergoing oxidation. Such redox are called as intramolecular redox. Clear, everybody? Make a note of that.
Of that sulfur. Sulfurs.
Every sulfur has -2 charge, right? But there are 2 sulfurs here. So total, how much charge it will have? -4. Right hand side, 2 sulfurs. We are checking out the charge. 2x plus 3 oxygens with -2. Overall charge is -2. So 2x is coming out to be 4. Which means for 2 sulfur, the charge here is +4. For 2 sulfurs, charge here is -4. So from -4 to +4, the value is increasing, which means it is oxidation. Same way, there is one more out of 3 sulfurs, 2 sulfurs I gave here. 1 sulfur is remaining. So 1 sulfur has -2, which is undergoing SO4 2 minus. So I can say from -2, it is going to +6. So this is also undergoing oxidation. Yeah?
Yes, sir, understood.
Make a note. So I guess all of you got a gist of the type of redox reactions. There are 3 redox reactions: intermolecular, intramolecular, and disproportionation. Shraddha, can you see it now? Everyone, those who are attending the sessions, okay, make sure that you fill the KVPY forms if you haven't filled it. Today is the last date. Okay.
Sir, can you zoom the last?
Finished? Right.
1
So,
minute.
like I said, we have three types of redox reactions: inter, intra, and disproportionation. Okay. Now, students, our objective is to balance the redox reaction. So, पहले तो हमने ये पता किया कि redox reaction होता कैसे है. अभी हम लोग क्या करेंगे, उसको balance करेंगे. Right. So, this is a biggest part of the redox, balancing the redox reactions. Finished? So now give the heading as balancing redox reactions. Balancing redox reactions happens in three mediums: acidic, basic, and neutral. So first we'll discuss the acidic medium. So in acidic medium, how do we balance the redox reaction? Okay, that's what we will see. So I'll take with an example. For instance, if we take KMnO4, and we were given FeSO4, which is becoming Fe2SO4 thrice plus K2SO4 plus MnSO4, and it has been just mentioned H plus. So you need to figure out that this is in acidic medium and redox current. Correct? So there are many methods of balancing it, beta. Okay, so the most or the best method for balancing is the ion electron method. The first thing what we'll do, we'll try to figure out which is undergoing oxidation, which is undergoing reduction. So ये question हमने पहले किया हुआ था, मैं directly ले रहा हूँ that manganese was undergoing reduction. This is what we have seen. And then we have seen iron was undergoing oxidation. So we have seen that iron is undergoing oxidation. So जो particles which are not part of redox, like K2SO4, it is not a part of redox. उसको लेने की जरूरत ही नहीं. We don't have to write it at all. So we directly take the molecules which are undergoing redox. So that is the first step. First step or step 1 is to ignore molecules or ions which are not part of redox reactions. Okay. Now, if at all I write the reaction, it will be KMnO4 plus FeSO4 in H plus, giving Fe2SO4 thrice plus MnSO4. This is what we have. Okay. Again, now the second step is to ignore the ions, write everything in ions first and ignore the ions which are not part of redox. Now I can write this as K plus and MnO4 minus, Fe plus 2 and SO4 2 minus, right? And left hand side 2 Fe plus 3 and 3 SO4 2 minus plus Mn plus 2 plus SO4 2 minus. Now again you can see that here K plus SO4 2 plus SO4 2 plus here and SO4 2 minus here. These are not participating in redox at all. So usko bhi ignore kar do, right? So you don't have to write down. So all you need to write is the parts which are undergoing oxidation and reduction. So this is undergoing oxidation and one is undergoing reduction. Right. So this is the first thing you have to do. So the step 1 is always about ignoring ions or part of molecules which are not a part of redox. Now see step 2. Step 2 is to separate half reactions. Separate of the half reactions. What are the half reactions here? We can see MnO4 minus is changing to Mn plus 2. We have seen this is reduction and this is a half reaction. So we say this is reduction, R reduction, H means half, means R, RHR means reduction half reaction. Clear students? What we have written is reduction half reaction. Similarly, Fe plus 2 changing to Fe plus 3. This is oxidation half reaction. So we have written OHR and RHR. And OHR represents oxidation half reaction. RHR represents reduction half reaction. Now see the number of electrons and their oxidation states. Manganese here was +7 oxidation state. Here it is +2. So the number of electrons transfer between them are 5 electrons. Because from +7 to +2, it is getting reduced, which means 5 electrons had to be added. And here one iron is +2 and here one iron is +3. So there is 1 electron transfer here. So Fe plus 2 is releasing 1 electron to become Fe plus 3. Now students, in a redox reaction, the primary thing we need to notice is that the number of electrons given and the number of electrons taken must be same. ऐसा नहीं हो सकता है कि number of electrons given and taken are different. Hence, I can say to keep the number of electrons same, I will multiply this entire equation by 1 and I'll multiply this entire equation by 5. Right? On doing that, what do I get? This equation does not change. It will be still MnO4 minus, giving Mn plus 2 plus 5 electrons. While this will become 5 Fe plus 2 changing to 5 Fe plus 3, giving out 5 electrons. Because now you have multiplied 5 on the entire equation. And now you will add both of them. So RHR plus OHR, again we will get the overall equation. So that is MnO4 minus plus 5 Fe plus 2 is becoming Mn plus 2 plus 5 Fe plus 3. Right, students? Now this is called the electron balanced redox reaction. Electron balanced redox. So we have balanced the electrons given and taken. So step 2 is clear, everybody. So step 1 is always about writing only the redox part. Step 2 is balancing the half reactions and trying to make sure that the number of electrons given and taken are same. Okay. Now let us see what is step 3. Step 3 here sorry, is to find what is the solvent we are taking, what is this medium which we are taking. Here I took acidic medium. Here I took acidic medium. So what we do, first we'll take this balanced equation, electron balanced equation, and count the number of oxygens on the left hand side and on the right hand side. Oxygen count. Let's see how many oxygens are present, students. Left hand side we have 4 oxygens and that's it. So we have 4 here and 0 here. Okay. So we can say the number of oxygens on the left hand side is more and number of oxygens on the right hand side is less. So we say this is the rich side, rich oxygen side, and this is the deficient side. Okay. So according to the redox rules, if it is acidic medium, that is in acidic medium, if you have taken, add deficient side, balance deficient side by adding H2O molecules. And how many should I add? The difference between these two. The difference between these two is 4. So I'll be adding 4 water molecules so that the oxygen is balanced. Well, oxygen is balanced now because there are 4 oxygens extra which is supposed to come. And now I have added that. But to counterbalance that, which means you have H plus been added at the same time, right? Because you cannot add only oxygen. We have to add it like water. But in water, the hydrogen's number of ions will be different. So what we can say now? So this will become 8H plus, because if there are 4 H2, which means we have 8H plus. And from there you will get this. Okay, once again. Friends, so you can see 4H2O and counterbalance that with 8H plus. Okay. So on doing that, what do we get? We will get this as MnO4 minus plus Fe plus 2, 5 Fe plus 2 plus 8H plus is giving Mn plus 2 plus 5 Fe plus 3 plus 4 H2O. Right? Now check. This is the completely redox balance reaction. ये completely redox. अच्छा, ये redox है या नहीं है, ये कैसे पहचानेंगे? देखो, you can always check the total charge on the left hand side and on the right hand side. So you see, total charge always has to be balanced. So total charge, if you would look at it, this is overall giving -1 charge. 1 iron is +2, and here there are 5 of them, so +10. And there is 8H plus, so 8. So therefore we will have total charge of 17 plus 17. Let us see on the right hand side. 1 manganese is +2 here. 1 iron is +3. +3 into 5 makes it 15. Right? So total charge is +17. So hydrogen is balanced, oxygen is balanced, charge is balanced. Overall charge on both sides is also balanced. So this is a redox reaction. Has everybody understood this logic? Any doubt here?
Sir, if the charge is not balanced, we have to add electrons.
No, which means you have done it wrong. If you have done it correct, then charge has to balance. Okay. So that is an indication कि आपको फिर से एक बार दोबारा जाके चेक करना पड़ेगा कि इस स्टेप में आपने गलत किया.
Yes.
चलो, right from the start. What is the balancing reaction? Write down from acidic medium. Show the steps. जल्दी लिखना है सबको. लिखते समय सोचो मत, जल्दी पहले लिखो. लिखने के बाद पूछना अगर कुछ डाउट है. Let me repeat. First step is to ignore all the ions and molecules which are not a part of redox reaction. That is step number 1. Step number 2 is to write reduction reaction half and oxidation reaction half as a 2 separate equations. And within that, you will find how many electrons are being used for oxidation and reduction. Primarily, number of electrons given and taken should be same. So we are counterbalance that with multiplying with these numbers. So we have counterbalanced that. After counterbalancing, you add them. And then you'll get the third step and accordingly the final step. Okay. Do it.
Sir, show the step 1.
How to ignore molecules or ions. Have you recognized which is undergoing oxidation and reduction beta? Like manganese was undergoing oxidation, iron was undergoing reduction. We have seen that earlier also. You know? Once you know that, rest all the ions which are not a part, you can ignore it. Should I understood? Next. Jaldi karo beta. There are a lot of questions. Those who are done can start trying with the next question. K2Cr2O7 plus Na2C2O4 जो हमने ऊपर बैलेंस किया है ऑलरेडी. So आप चेक करके K2Cr2O7 Na2C2O4 write the oxidation states. Write the oxidation state on the right hand side also. See which is oxidizing, which is getting reduced.
Sir, show the step 3.
Do you naturally write very slow beta? So
No, sir, the screen was not clear.
okay.
Sir,
Yes, dear.
sir, I have a doubt in first step.
Okay, one second. Let me go back. Yes, tell me.
Sir, there are two Fe plus 3, na? So why have we written only a single Fe plus 3 there?
See, while balancing, whatever the reactant you are taking, as many number of iron molecules you are taking, the same number of iron should be appearing here. Okay.
Yes,
So that
sir.
is why, even though it appears like 2Fe plus 3, don't have to take 2 ना. Logically think करो, जितने reactants होंगे उतने ही तो product बनेंगे. This is called
Yes, sir.
atom conservation. Yeah.
Yes, sir.
Yeah. Now let us start with this. We'll do the first step. Now I don't write all the details. We just have to write the first step. First, I think all of you figured out what is getting oxidized and what is getting reduced. Chromium here is +6. Chromium here is +3. Carbon here is +3. Carbon here is +4. ये पहले कर चुके हैं हम लोग. So that's why I'm directly writing it. So +6 to +3 reduction. +3 to +4 oxidation. Okay. देखो बेटा, one thing you need to understand that only the metal ions which are present, right? उसको ही हम लोग separate कर सकते हैं, या कोई सल्फेट नाइट्रेट ऐसे जो आयंस होते हैं उनको सेपरेट कर सकते हैं. बट ऑक्साइड्स विच आर कनेक्टेड टू द मेटल reducing or oxidizing part, you cannot write them separately, you cannot ignore them. So if you write them in ionic form, the ionic form is this: 2K plus Cr2O7 2 minus. This is the way to write. Plus 2Na plus C2O4 2 minus, and that in the presence of H plus is giving 2Cr plus 3 SO4 2 minus plus K2SO4 plus CO2 plus Na2SO4. Right? Now I can see that we can see that this is the part which is going to get reduction. This is the point which is going to get oxidation, or reduced part, and oxidized part. बाकी सारों को हम लोग क्या करेंगे बेटा? Ignore. We will ignore this. We'll ignore this. We'll ignore this. We'll ignore this, and we'll ignore this. So what do we write? C2O4 C2O7 2 minus plus Cr2O7 2 minus plus C2O4 2 minus in acidic medium is giving 2Cr plus 3, or simply I'll write. Now I'll write 2Cr. Why beta? I'm writing 2Cr. Reason being there are 2 chromiums on the left hand side. I need to have 2 chromiums on the right hand side as well. Plus CO2. This is the one which you have. Again, you can see there are 2 carbons here. So I need to make 2 carbons on the right hand side also. So this is the first step beta. First step is writing the ionic form of the reaction. So this is writing the ionic form. Okay. Ignoring all the ions which are not a part of redox. See step 2 now. Step 2 is to write the RHR and OHR. See what is the RHR here? RHR is Cr2O7 2 minus is changing to 2Cr plus 3. 2Cr plus 3. Okay. Now count the charge for 2 chromiums here, because एक मॉलिक्यूल में 2 क्रोमियम है ना, एक ही मॉलिक्यूल में 2 क्रोमियम, तो आपको चार्ज दोनों क्रोमियम का लेना पड़ेगा. And you can see 1 chromium was +6 and 2 chromiums makes it +12, and 1 chromium on the right hand side was +3, so 2 chromiums together will make it +6. So how many electrons are transferred here? 6 electrons transferred. Now let us look at OHR. So in the OHR part, C2O4 2 minus is changing to 2CO2. Same thing here also. For 2 carbons, charge 1 carbon is +3, 2 carbons it is +6. 1 carbon is +4, 2 carbons it is +8. So the number of electrons transferred are 2. So ऐसे लग रहा है given is only 2, taken is 6. ऐसे तो नहीं हो सकता, right? Which means number of electrons given and taken should be same. So I'll have to multiply this with 3. Got it? And multiply the first one with 1. So now if you do both of them, we will get an equation now. That equation would look like this. So we'll have Cr2O7 2 minus plus 3 C2O4 2 minus is given up 2 Cr plus 3 plus 6 CO2 plus 6 CO2. Check this out. Clear, everybody? Any doubt in the second step? Right. Now we got a balanced equation, like how many electrons are being taken, how many electrons are being given. Yeah. This is the redox balance reaction. Now comes the step 3, which is the medium based. Step 3 is medium. And we are taking this as acidic medium. Since we are taking acidic medium, what is the first thing I said? Count the number of oxygens. So oxygen count. On the left hand side, how many oxygens we have? 7 plus 4 3s are 12. 7 plus 12. So 19 oxygens. So there are 19 oxygens. Right hand side, 6 2s are 12. So only 12 oxygens. So we have 12 oxygens. So we have 19 and 12 oxygens. What is the difference? So the difference here is 7. So there are 7 oxygens deficient. This is a rich side. This is a deficient side. So like I said, on the deficient side, always the difference number with water molecule. So 7H2O. And counterbalance that with 14H plus, which means double the number of H2O. So now if you write the overall reaction, C2, Cr2O7 2 minus plus 3 C2O4 2 minus plus 14H plus is giving 2 Cr plus 3 plus 6 CO2 plus 7H2O. Everybody make a note of it now. If there is any doubt, you can ask me. Why 7H plus beta? Shraddha, you have to double. You can see here there are 7H2O. 7H2O means how many H plus will be there? 7 2s are 14. So counterbalance by 14H plus. Okay. Make a note. Why don't we write the ignored ions in the final balanced reaction? Honestly, it is not required, okay, because they are all in solution, beta. They are in all ionic form, so we don't have to write it. But even if you write, I'll show you, even if you write, it does not make any problem. See, you have K2Cr2O7. This is how it was, plus 3 moles of Na2C2O4 plus 14H plus. 14H plus means it is coming from 7H2SO4, right? You can take 7H2O4 as the acidic medium, and that will be this Cr2 plus 3. I will write it as Cr2SO4 thrice plus 6 CO2. And you can see there are 2 potassiums here, which means I can have K2SO4. And you can see there are 6 sodiums here, which means I can have 3 Na2SO4 plus 7H2. Now check this out, it is perfectly balanced. Shraddha, clear? But that is not asked to you, so you don't have to worry about it. Okay. How do we verify? Like I said, last step is the verification step. So how do we verify whether this balancing is correct? Let's just check out the overall charge. See the charge here, beta. Here overall charge is -2. Here it is -6. Here it is +14. So total kitna hai? So -8 plus 14 here. So which is 6, right? See here, 3 2s are 6. This is 0, 0. So 6 and 6 balanced. So which means whatever we have done is correct. So acidic medium is clear to everyone. Now let us see the similar reaction, but this time in basic medium. Okay. Let's see. Basic medium balancing. Only the last step changes, beta, nothing else. Only the balancing of oxygen which we were doing, बस वहीं पर change आएगा. बाकी सब the way we have done it earlier, that is what you have to do. So see, MnO4 KMnO4 plus NaI is giving MnSO4, right? Sorry, MnO2 plus IO3 minus, or simply read as KiO3 plus Na2 plus NaOH. No, sorry, simply, yeah, NaOH and KOH, that's it. NaOH and KOH. Something like this is present. Okay. Now we have to do this balancing in basic medium. Got it? The logic is same. First write the ions, ignore everything which is not a part of redox. So we can say K plus MnO4 minus plus Na plus I minus MnO2. We cannot separate oxygens, but we can separate K plus IO3 minus plus Na plus OH minus K plus and OH minus. This is how it. Now you can see only these two are participating here. Manganese to MnO2. This is changing. I minus to IO3 minus. This is changing. Rest all are ignorant, which means I can ignore this, this. I can ignore here, this one, this one, this one. All this I can ignore. So if you write the electron redox part of it, NaO4 minus plus I minus is giving MnO2 plus IO3 minus. This is the first part. So second part, or second step is about balancing it. So MnO4 minus is going to become MnO2 and I minus is going to give us, I minus is becoming I2. Okay. Check out the oxidation states here. Manganese here is +7. Manganese here is +4. Number of electrons transferred are 3. Right. So here it is IO3 minus. So iodine here it is -1 and 1 iodine here calculated x plus 3 times of -2 overall equal to -1. So x is equal to +5. So iodine here is +5. -1 to +5, how would I get? First -1 to 0, 0 to 1, 1 to 2, 1 to 3, 4, 5. Correct? So which means total number of electrons transferred are 6. So 6 electrons are transferred. How do I counterbalance this? This is RHR, which I'll multiply that with 2. This is OHR, which I'll multiply that with 1. And from there, we will get the overall reaction, which is 2 times of MnO4 minus plus I minus is becoming 2 times of MnO2 plus IO3 minus. Plus IO3 minus, right? So this is the ionic balanced or the electron balanced redox reaction. Now second step is done. So up to second step, there is no change, but it is the third step where you have to be clear. So in the third step, while balancing, now you need to count the oxygen. So how do we balance oxygen? Count oxygen. Left hand side, 4 2s are 8. So there are 8 oxygens. There are 8 oxygens here. Right hand side, 2 2s are 4. 4 plus 3, 7. So there are 7 oxygens here. Clear? I guess up to this point, everybody understood. Right. So the difference in oxygens, is only 1. So there is 1 oxygen difference. And which is the rich side here? This is the rich side. This is the deficient side. Now, how do we do this? On the rich side, students, we will be adding, on the rich side, we'll be adding water. Unlike the earlier case, in basic acidic medium, we used to add water on the deficient side. But in basic medium, we will always add water on the rich side. We'll add water on the rich side and counterbalance that with double the number of OH minus. We'll counterbalance that with double the number of OH minus. So what do we have here now? 2 MnO4 minus plus I minus plus H2O is becoming 2 MnO2 plus IO3 minus plus 2 OH minus. Now this is the overall balanced reaction. Clear, students? Make a note. Faster, guys.
Can you zoom the second?
What, beta?
Zoom the second step.
Check. Finish there, everybody. Now, students, balancing in basic medium or aqueous medium is same. So there are literally two rules. One is for acidic medium, one is for basic and aqueous medium. So basic and aqueous medium are same. Done, everybody. All the steps are done. So we'll do one more question on basic medium. You see, suppose Cl2 plus NaOH if you have, and that is going to get oxidized as Cl NaOCl plus NaClO3. So this is the case. So for this, we have to balance the reaction to that. Cl2 plus NaOH is giving NaOCl and NaClO3. सब लोग आप खुद से try करोगे अभी. Check which is the element which is going oxidation or reduction. So all of you got some head start. Meanwhile, I'll keep solving. जो खुद से कर रहे हैं वो प्लीज करेंगे, जो अटक गए, जिससे नहीं हो रहा है, प्लीज check on the book, check on the screen. Sorry, here there is no oxygen, my mistake. NaCl, this is. Let's correct that, students. Clear so far? So you can see from Cl2 it is changing to ClO3 minus, and from Cl2 it is changing to Cl minus. And I hope you understood why I have written 2 chlorines here, because there are 2 Cl2 here. One Cl2 will have 2 chlorines, and to make sure there are 2 chlorines here also, I have multiplied 2 here and 2 here. Now count the number of electrons. From 0, for 1 chlorine it is plus 5. So for 2 chlorines it is plus 10. So 10 electrons are exchanged. So for 2 chlorines it is 0. For 2 chlorines it is minus 2. So 2 electrons are exchanged. So if you counterbalance that, we have to multiply this with 1, and we have to multiply here with 5. Now on adding, we will get this as Cl2 plus 5Cl2 is giving us 2ClO3 minus plus 10Cl minus. So here it is going to be 6Cl2 becoming 2ClO3 minus plus 10Cl minus. Now this can be further balanced by removing one common term here. I can take 2 as common, so I'll get this as 3Cl2 becoming ClO3 minus plus 5Cl minus. Up to this, we have made an ion balanced redox reaction. So electron has been balanced up to this point. After electron balanced redox reaction, now we will take the medium. Medium is basic. So for that, we need to count the number of oxygens, left hand side and on the right hand side. So oxygen count, if you see it on the left hand side, it is 0. Right hand side, there are 3 oxygens. So delta is 3. And like I said, on the rich side, we'll be adding water. This is the rich side, so I'll be adding 3 times of water. And on the deficient side, we'll be adding 6 times of OH minus. Double the number of that. So we can see what is the product we'll get. 3Cl2 plus 6 OH minus is going to give us ClO3 minus plus 5Cl minus plus 3H2. Check this, everybody, if you have understood that or not. Anyone has a doubt, they can ask me, or else finish all the steps. We'll go to the next question. Done, everybody?
Sir.
Okay, what about OH minus from NaOH? Do we ignore the H here? See, NaOH is a basic medium beta. That is to show that it is a medium used, Shraddha. Okay. That's why I have not written it here while balancing it. At the end, we have anyway got this, right? That is a NaOH. So 3Cl2 plus 6 NaOH is giving NaClO3 plus 5 NaCl plus 3H2. Right. So have all of you understood that? Right. Shall we go ahead? Anup, have you finished?
Just 1 second.
Now, students, the next important thing what you will face, one is we learned how to redox the balance reaction. Second thing is to find something called equivalent weights. Now, this comes with the idea of something called equivalents. Now, equivalents and moles are pretty much the same. When we define moles, we say it is weight by molecular weight. Similarly, when we define equivalents, it is defined as weight by equivalent weight. Weight by equivalent weight. Clear? So what is this difference between molecular weight and equivalent weight? Now, equivalent weight is defined different for different species. For example, for acids, if you see equivalent weight is defined as molecular weight divided by number of ionizable H plus ions. For bases, equivalent weight is defined as molecular weight by number of ionizable OH minus. And for salts, equivalent weight is defined as molecular weight by charge on the salt. How much charge the salt possesses. What does this mean? For instance, if I take H2SO4, the minute you add it to water or in generally for any reactions, it will give away 2 H plus and becomes SO4 2 minus. So how many H plus it is giving? It is giving 2 H plus. So that means it has 2 ionizable H plus. H3PO4, if you treat with maybe NaOH, and we are saying that it is forming Na3PO4, which means H3PO4 is giving all its hydrogens to react with NaOH so that all hydrogens are replaced with sodium. So we say that it has 3 replaceable hydrogens or 3 ionizable hydrogens. So this factor 2 here, like 2 here, 3 here, that is called, that is the value that is coming in the denominator. Similarly, one value come in the denominator here, the one value come in denominator. So in general, what we say, whether it is acids, bases or salt, equivalent weight is equal to molecular weight by a value, and that value is called valency factor, or it is also termed as N factor. So I can write it as N factor, or it is also written as molecular weight by VF, which is valency factor. So whether it is for acids, bases or salt, there has to be divided by some number. Okay. Now I'll take few examples and explain you how to calculate the equivalent weight. So for instance, if at all I give you H2SO4, H3PO4, H2C2O4, got it? And HNO3, HCl in all of these cases. Now if you see how many ionizable H plus it has 2, 3, 2, 1 and 1. So these are the ionizable H plus. So that means valency factor is 2, 3, 2, 1, 1. We know the valency factor, and the equivalent weight is molecular weight by its valency factor. So for example, H2SO4, molar mass is 98, valency factor is 2. So the equivalent weight is 49. Clear, students? So that's how we need to figure out what is the valency factor, what is the equivalent weight. So equivalent weight, H3PO4 is also 98 molar mass divided by 3. Here, equivalent weight, H2C2O4 is 62 divided by 2. Equivalent weight of HNO3, right? Whatever its molecular weight is divided by 1. Okay. Similarly, equivalent weight of HCl, molecular weight divided by 1. This is all for acids, students. For acids, this is how we calculate the equivalent weight. For bases, like NaOH we have, BaOH twice we have, AlOH thrice given. So valency factor in the first case is 1, here it is 2, here it is 3. So equivalent weight will be molecular weight divided by 1. Equivalent weight here will be molecular weight divided by 2. And equivalent weight will be equal to molecular weight divided by 3. So that will be the valency factors and equivalent weight for bases. Salts. Now salts, you need to check the total positive charge. For example, if I take K2SO4, K2SO4 will split as 2K plus SO4 2 minus. So the total positive charge is plus 2. Hence, equivalent weight here will be molecular weight divided by 2. Here it will be molecular weight divided by 2. Suppose if you have Al2SO4 thrice, and here there are 2 aluminium plus 3 SO4 2 minus. So you can see this is 3 times of 2, which is 6 plus 6, which means equivalent weight will be equal to molecular weight divided by 6. That will be the equivalent weight. So I think all of you got a logic, like in acids, bases and salt, how to calculate the equivalent weight. Same way, equivalent weight when it comes to redox reactions now. In redox reactions, equivalent weight will be equal to molecular weight divided by number of electrons transferred. Whether it is oxidation or reduction, but how many electrons are transferred, that defines the equivalent weight. For example, if you take KMnO4, we saw that in acidic medium it will change to Mn plus 2. And same KMnO4, if you take basic medium, concentrated basic medium, it will change to MnO4 2 minus. And same KMnO4, if you take it in aqueous medium, then it will convert to MnO2. Correct? Now, what is the equivalent weight here? Depends upon how many electrons are transferred. You can see manganese here is plus 7, here it is plus 2. How many electrons are transferred, student? 5 electrons. Here it is plus 7, here it is plus 6. So 1 electron. Here it is plus 7, here it is plus 4. So how many electrons? 3 electrons. So we can say that in the first case here, the equivalent weight, in this case, the equivalent weight will be equal to molecular weight divided by 5. So molecular weight of KMnO4, that divided by 5. Second case, equivalent weight will be equal to molecular weight divided by 1. Third case, equivalent weight will be molecular weight divided by 3. So that's how we calculate the molecular weights. I mean equivalent weights. I hope all of you got this. Acha, students, these three, right? These three are very commonly asked. तो आपको ये याद होना चाहिए that KMnO4 changes to what in acidic medium, basic medium, and aqueous medium. So this aqueous medium is also sometimes called as dilute OH minus or dilute alkaline. Dilute alkaline case or H2O case is same. Concentrated OH minus is a different case. Now this is about KMnO4. Similarly, if you take K2Cr2O7, K2Cr2O7 in acidic medium will always convert to 2Cr plus 3. Now for 2 chromiums, it is plus 12. For 2 chromiums, here it is +6. So number of electrons transferred are 6. So we can say equivalent weight of K2Cr2O7 is molecular weight by 6. Now students, these have been directly asked in questions, like in KVPY questions directly been asked, what is the valency factor of KMnO4, or what is the equivalent weight of KMnO4 in basic medium, or in concentrated basic medium, or all simply dilute alkaline, or water, or K2Cr2O7. All of these questions have been asked. So you must know how to find the equivalent weight in all these cases. Make a note of it, everyone. Write down the definition. What is equivalence? What is equivalent weight? Anjali, what happened, beta? You're having issues with the internet today?
Yes, sir.
Watch the recording later properly once again. Okay. Again, it started raining in Kolhapur.
Yes, sir.
Bad. Usually it rains a lot in Kolhapur?
No, sir.
No. Okay, you're in Ahmednagar. Finished? Do it for bases and salts. Gave you some examples. Look at it. Bases and salts. Done, everybody?
No, sir.
ठीक है करो करो. Finished. Now look at it. So what we got is the equivalent weight in various cases. Now, our objective mostly is confined with the equivalent weights in redox reactions. So if you look at it, like we learned one redox reaction here, like KMNO4 treating with I minus give I2 plus Mn plus 2. This is what is happening. Now I want to find out the equivalent weight of KMNO4. So what I can say? So from manganese here to here, how much is the change in oxidation state? It is +7 to +5 plus 2. So 5 electrons been transferred. And similarly, if you check out I minus to I2, so here it is -1 and here it is 0. So there is only one electron transferred. Okay, 1 second. So here we have one electron being transferred. Here we have 5 electrons. So I can say equivalent weight of KMNO4 is molecular weight by 5. And here equivalent weight is equal to molecular weight by 1. Equivalent weight is equal to molecular weight by 5 and equivalent weight is molecular weight by 1. Ye clear hai? Everybody understood that? How to find the equivalent weight? The problem comes to find out the equivalent weight in a disproportionation. और ये must question है बेटा, अब ये अच्छे से करेंगे सब लोग. Please 2 minutes अच्छे से ध्यान से रखो. Okay, watch it patiently and try to understand every step. When it comes to disproportionation, finding out equivalent weight is a very different case. For example, let me take the disproportionation reaction like I2 in basic medium is changing to I minus plus IO3 minus. If this is how it is given. How to balance this मैंने बताया है इसको. इससे पहले यही क्वेश्चन किया था मैंने Cl2 लेकर. Cl2 is giving Cl minus and ClO3 minus. But this time I'm taking I. If you see the oxidation half reaction, this is I2 change into IO3 minus. This is OHR. And then I2 change into I minus. This is RHR. Now here, like you can see that there are two iodines on the left hand side. So I need to have two iodines on the right hand side. Two iodines on the left hand side. So I need to have two iodines on the right hand side. This side also. Now see the number of electrons transferred. So from here 0, and for one iodine it is +5. For two iodines it is +10. Here it is also 0. For one iodine it is -1. For two iodine it is 2. So we can clearly make out the number of electrons transferred is 10 electrons here, and here it is 2 electrons. Now we have to calculate equivalent weight individually first. So equivalent weight of I2 in this case, in OHR case, okay, or equivalent weight in OHR case will be equal to molecular weight of I2 divided by 10 electrons. Equivalent weight in the case of RHR will be molecular weight of I2 divided by 2 electrons. Okay. Now you have to average them. मतलब दोनों को add करोगे तो overall reaction का आ जाएगा. So equivalent weight of overall reaction, that is I2, will be equal to molecular weight of I2 by 10 plus molecular weight of I2 by 2. So if we do that, we are getting this as 6 Mi2 divided by 10. So which is Mi2, that is molar mass of I2 divided by 5 by 3. So I hope now you understood the valency factor for I2. The valency factor of I2 is 5 by 3. It is coming out to be a fraction. So that's why it is important to calculate the equivalent weight in disproportionation reaction. So in disproportionation, OHR का अलग से calculate करो, RHR का अलग से calculate करो, फिर दोनों को add करो. That way you will get the overall molecules equivalent weight. Make a note, everyone. Aryan is absent. Kirti is absent. Krisha is absent. Shruti, Shreya are present, na beta? Yeah.
Yes, sir.
Done, everybody? Mainly this is the part which is there in redox reaction, students. आपको कैसे बैलेंस करना आना चाहिए, acidic medium, basic medium, right? Second thing, understand the equivalents, calculate equivalent weights in all the cases. Remember KMnO4 and K2Cr2O7. Okay, these two are the most ones which are asked. KMnO4 कैसे चेंज होता है, K2Cr2O7 कैसे चेंज होता है. देखो, K2Cr2O7 का मैंने बेसिक मीडियम में इंटेंशनली नहीं लिखा क्योंकि बेसिक मीडियम में K2Cr2O7 का कोई रिडॉक्स नहीं होता. So K2Cr2O7 only in acidic medium it will become Cr+3. Nothing happens in basic medium. In KMnO4 in acidic medium, aqueous medium and concentrated OH- medium. In all of these cases, you should know their valency factors, their equivalent weights, what they are changing. Simple objective questions are made from this area. You will get at least 3 questions from this entire stoichiometry every year. Okay, in the essay exam. So understand that. One, you will get acid-base reaction, simple acid-base. One is on the basis of mole. One is only on the basis of this valency factors. And the fourth question, which is a mixture of both electrochemistry and redox, where you will have this equivalent weights. So equivalent weight concept will come. So these 2 chapters include at least 4 to 5 questions. So learn it carefully, right? So you will be in a much better hand while, once you go for KVPY exam. Okay, students? Right. So I'll end the session here now. So
sir, I have one doubt.
Yes, dear. Yes, dear.
Sir, what is the mark distribution of KVPY paper?
KVPY paper? It usually changes, but it is always, mostly it is always +4 and -1. Okay.
Sir, no, actually, I have seen that some questions are of 3 marks, some are of 1 marks.
There are 2 sections. Okay. First section will have +4 and first section do not have negative marking sometimes. And last year they introduced negative marking also. They made it as +3 -1. Okay. Second section has 5 questions each, like 5 questions chemistry, 5 questions bio, 5 questions physics, 5 questions from maths. So that is made as +4 and -2. Okay, that is relatively difficult.
Okay, sir, clear.
Bye, sir. Total we have 25 questions. 20 questions. Yeah.
Bye, sir. Done, sir.
Okay, guys. Bye. See you.
Thank you, sir.
Okay, beta. Bye.
Bye, sir. Thank you, sir.
Bye, beta.